Okay, so we've been changing complex numbers to polar form. Let's just do it one more time. Um, and actually, let's not, let me just recall. The last example was this type of a problem. So complex to polar, complex to polar. All right, we need to do one the other way, okay? So let's do example 11, which is on page 534, but we're gonna do it here. So now we're gonna take a polar and go back to complex. Now this is actually a lot easier. So we're gonna have our friends right here. X equals r cosine theta, y equals all the same things. You have those on your little sheet. And we're going to use those. So first identify what's r. Oh, it's 3. Remember, r e to the I theta, that's our other friend. Okay, so r is 3, and what's my theta? Pi over 6. So that's what you do. You just identify the r and the theta and plug them in right here. So x equals r cosine theta, and 3 times the cosine of pi over 6, since it's on the unit circle, piece of cake. Cosine of pi over 6, let's see, pi over 6 is this guy, the cosine is the square root of 3 over 2, so it's 3 radical 3 over 2. Y equals r sine of theta, which is 3 times the sine of pi over 6, which is the 1/2, or 3/2. So our a plus bi is the same as x plus yi. So it's going to be 3 radical 3 over 2 plus 3 over 2. These are the nice problems, okay? Okay, so now let's go into the next skill. To find a power of a complex number, okay? Something like this. Taking this to the 6th power, one way to do that is to write this out 6 times. Let me just illustrate this. This is worth seeing. So you know, -4 plus 4i times -4 plus 4i times -4 plus 4i times -4 plus, sorry, I know this is like crazy, but this is why we love polar coordinates. Because if we change this to polar coordinates first, then we can, it's so much faster. Okay, otherwise we'd have to FOIL this out and get 16 minus 32i plus 16i squared. Simplify that and distribute it with this one. Simplify that and distribute it with this. Oh my gosh, not going to do it. All right, there's got to be an easier way, and some mathematicians said the same thing. So they said, here's the 3 rules, and it's actually in your textbook right here on page 534. Convert to polar form. Yes. Raise to the power using exponent rules. We just use what we already know and convert back to a plus bi. Now, there is a man who came up with this, and he is famous for doing this, and he's called de Moivre. De Moivre's theorem, it says exactly what, it's in the old form though. It's in the form that's a little bit harder and a little more confusing. So we're going to do it in the simple form to show you why it's so simple. Okay, but he gets the credit because he's the one that came up with it. All right, so first of all, convert to polar. So let's see what this looks like. Forget about the 6th right now. We're just taking -4 plus 4i to polar, and then we'll take that to the 6th power. Okay? All right. So we've got -4, 4. Oh, we've done this one already. It looks familiar. -4, 4. So r is going to be the square root of x squared plus y squared, which is 16 plus 16. Square root of 32 goes into 4 radical 2. Okay, just doing that again doesn't hurt. So there's my r. Now my theta is in quadrant 2, and I already know if the tangent is -1, it's pi over, or 3 pi over 4. Okay, because look at your unit circle. Okay, so theta equals 3 pi over 4. So to write this in polar coordinates would be 4 radical 2 e to the 3 pi over 4 I. Okay, now I'm taking that to the sixth. Well, here's what we do. You take 4 radical 2 to the sixth, and then you take e 3 pi over 4i to the sixth. And this to the sixth we can do on our calculator. This to the sixth we'll do in our head. But first, let's go ahead and do parentheses 4 radical 2 parentheses, oops, 2 parentheses. Okay, so 4 radical 2 to the sixth. I got 32,768. And then if you remember our exponent rules, if there's a parenthesis, we multiply those. So that's going to be e to the 3 pi over 4 times 6. Okay, and that's 18 over 4, or 9 pi over 2. 32,768. 9 pi over 2i. Okay, now that's not on the unit circle, 9 pi over 2. Your textbook is going to say that's okay. I'm going to ask you to change 9 pi over 2 back to a coterminal angle on the unit circle. So minus 2 pi, so that's 4 pi over 2, gives me 5 pi over 2, and minus 2 pi again. Now I can see that it's pi over 2. So my final answer would be 32,000, not my final polar answer, e to the pi over 2i. Okay, now let's change that to right here, standard form. So we did the polar form. Okay, now standard form is this, a plus bi, or x plus yi. So we need x. So what do we have? We have our r, and we have our theta. And this is the easy part. Remember, all we have to do is x equals r cosine of theta. Sorry, that's not pi. Okay, so let's take 32,768 times the cosine of pi over 2. And if you remember, on your unit circle, the cosine of pi over 2 is 0. So that's 0. And my y equals r sine of theta. That's going to be 32,768 times the sine of pi over 2, which is 1. So y equals 32,768. So my final answer, a plus by, or x plus yi, is going to be 0 plus 32,768. Throw an I on there, and that is my answer in standard form, or what we call in standard form or complex number. Okay, go back to your textbook. I just want to, again, one more time, give him credit for doing this. All right, that's it. Okay, so let's do a few more problems. Let's see. We've got example 13 in your textbook. And it says evaluate the square root of 9i using polar form. So we're going to first take the steps right in exponential form, and then we're going to write it in polar form, and then using rules to simplify. Okay, so let's rewrite the square root of 9i first as 9i to the 1/2 power, and then we want to write that in polar form. All right, and so let's see, polar form, we need a r and we need a theta. Okay, so remember, we're just doing the 9i, and then we'll put that to the 1/2 power. So 9i, I'm going to just graph that real quick. 9i is really the same as 0 plus 9i, so that's up here. And that looks like my r is going to be 9, and my theta is going to be pi over 2. So we can just write 9e to the pi over 2i. And then we'll take that to the 1/2 power. Okay, so we plotted it. Let's exponent rules. So 9 to the 1/2. Okay, and then e pi over 2i to the 1/2. So the square root, remember 1/2 is the square root. So the square root of 9 is 3. And then we'll distribute this in. E to the pi over 2 times 1/2 pi. And then that gives us pi over 4. So that's 3e to the pi over 4I. Okay, now that's my polar form. They want it to a plus bi, so that gives me r is 3, theta is pi over 4. So now I just go back to x equals r cosine theta. So that's 3 times the cosine of pi over 4, which is 3 times radical 2 over 2, or 3 radical 2 over 2. And y equals r sine of theta. And so that's the same as 3, the cosine of, oops, the sine of pi over 4 is the same as the cosine of pi over 4. So that's going to be 3 times radical 2 over 2, or that's my answer. So I'm just going to put an I on that one. X plus yi. There we go. Let's do one more. All right, first step, change the square root of 3 plus I to polar form. I need my r and my theta. Then I'll take that to the 6th power. Okay, so graph it. Square root of 3 of I. Okay, there's 1. I know that. And then the square root of 3. This is on the unit circle, I can tell. Okay, so r is going to be the square root of x squared plus y squared, right? X equals radical 3, y equals 1, okay? And so that is the square root of 3 plus 1. So r equals 2. And theta, look on your unit circle, tangent 1 over radical 3, that is going to be pi over 6. So I'm going to rewrite this as r e to the pi over 6 pi. Then I take it to the 6th power, so that's 2 to the 6th, e to the pi over 6 times 6, okay, because we're timesing those, and that's 6 over 1, so that's going to cancel. So we get 2 to the 6 is 2, 4, 8, 16, 32, looks like 64, e to the pi I. All right, now that's one answer. Now I'm going to ask you to write it in standard form. Now this is the polar form, but to write it in standard form, no problem. R equals 64, theta equals pi, x equals r cosine theta, 64 times the cosine of pi. The cosine of pi over here is -1, so x is going to be -64. Y equals r sine of theta, which is 64 times the sine of pi, and the sine of pi is 0, so y is going to be 0. My answer is -64. 2 answers. Polar coordinates, standard form, and let's take a break on this.